Boom! Think about your brain right now. It is a 3-pound universe of electricity and flesh. It holds your memories. It builds your dreams. It lets you read these very words. Now, imagine plugging that universe into a supercomputer. Imagine your thoughts moving at the speed of light. Imagine solving problems that take lifetimes in just a few minutes. This is not a story from a distant future. This is a journey we are on today. Scientists are building the tools to unlock this power. We are on the edge of a new era, an era where the human brain begins its next great evolution. This journey is not about replacing what makes us human. It is about expanding it. We are not building cold, calculating machines inside our heads. We are building partnerships. Think of it like a pilot in a jet. The pilot has human skill. The pilot has intuition and courage. The jet has incredible speed and power. Together they can fly across oceans. Neither could do it alone. We are learning how to build the jet for our minds. Before you can upgrade a city, you need a map. The brain is the most complex city in the known universe. It has about 86 billion buildings, which we call neurons. These neurons are connected by trillions of roads, trillions of pathways. To understand how the brain works, we must first map these connections. This massive undertaking is called connectomics. It is like creating a perfect street-level map of New York City, but for every single wire and connection inside your head. Scientists use powerful microscopes that can see things smaller than a wave of light. They slice brain tissue into layers thinner than a human hair. A computer takes pictures of each slice and stacks them to build a 3D model of neurons and their connections. This shows us exactly which neuron talks to which other neurons. We can see the superhighways of thought and the quiet side streets where memories might be stored. This map is the fundamental blueprint for everything else we want to do. If you know the roads, you can predict the flow of traffic. With a brain map, we can see how a signal for a thought or a movement travels. We can see where a problem, like an epilepsy, might create a traffic jam. The map reveals the brain's logic, the structure behind every idea, feeling, and action. This is not just abstract knowledge, it gives us precise targets. If we want to help the brain learn faster, the map shows us which pathways to focus on. It is the guide for all future work. This mapping process is slow and incredibly detailed. Mapping a brain the size of a poppy seed can take years. But our tools are getting faster every day. AI helps us trace the connections automatically. New imaging techniques let us see these connections in living brains. We are moving from still photographs to live video of the brain's activity. The map is coming to life, transforming into a dynamic, real-time guide to the living, thinking city inside our skulls. This living map is the first key to unlocking the supercomputer within. Once you have the map of the city, you need a way to listen to its conversations. The brain speaks in tiny electrical pulses. To connect a brain to a computer, we need a translator. These translators are called brain-computer interfaces, or BCIs. They can read the electrical signals of neurons and write signals back. A BCI is like a modem for your mind. It turns analog chatter into digital code, our bridge between biology and technology. There are different kinds of BCIs. Some are like listening from outside the city walls, non-invasive EEG caps that pick up broad brain rhythms. They can tell if you are focused, relaxed, or sleepy. Great for simple commands like moving a cursor or playing a basic game. They are safe and easy to use, but they hear the roar of the crowd, not the whispers. To hear whispers, you go inside the city. Invasive BCIs, tiny electrode arrays on the cortex or even among neurons, listening to individual brain cells. This gives a much clearer, more detailed signal. With this detail, a person who is paralyzed can think about moving their arm, and a robotic arm will move. The BCI translates thought into command. BCIs are not just for reading thoughts, they can write information back into the brain. A camera feeding a visual cortex implant can let a blind person perceive simple shapes. Light. A robotic hand with sensors can send touch back to the brain, letting a person feel texture. This is where the partnership truly begins. Having a map and a translator is not enough. The brain produces a flood of information, billions of neurons firing every second. We need help. AI and machine learning are the smart partners. They find patterns in BCI signals, like the thought, "move my hand left." They learn the brain's unique language, much like learning to hear hello and goodbye in a new tongue. A person repeats a thought. The AI listens, learns the neural pattern, and later recognizes it instantly. Then it goes further, anticipating intentions, smoothing and fine-tuning movement like a helpful assistant. AI filters noise and focuses on important signals, making control smoother. It also helps the brain learn, sending positive feedback when actions succeed. This reinforcement learning creates a loop where brain and AI learn together. They become a hybrid team. This learning loop turns a simple BCI into a dynamic, intelligent extension of the self. Traditional computers are powerful, but they do not think like brains. Your phone uses a central processor, doing one thing at a time, very fast. The brain is massively parallel. Imitating the brain with old chips burns energy and heat. To partner with the brain, we need new hardware, neuromorphic hardware, designed to mimic neurons and synapses, combining memory and processing. Digital neurons communicate and only use energy when they fire, like real neurons. Incredibly efficient. They handle messy real-world data, recognizing faces, understanding speech, on tiny power. Imagine connecting one directly to a BCI. The brain has a thought. The BCI reads it. The neuromorphic chip understands instantly and commands a device. The system becomes wearable, even implantable, removing lag. Thought to action feels seamless, like moving from dial-up to fiber for your mind. This hardware is the missing piece, the engine that runs the AI and talks to the BCI, making everyday brain-computer partnership practical. Smart glasses that identify objects in real time. Prosthetics that move and feel like real limbs. A physical bridge where digital and biological worlds merge. This journey is thrilling. It promises healing and expanded potential. But we must walk this path with our eyes wide open. We are touching the core of personhood, accessing the most private space in the universe, the human mind. This demands new ethical thinking. Build guardrails now. Who owns your thoughts? If a company makes the BCI and the AI, do they see your data? The privacy of our minds must be absolute, protected by the strongest laws and security on Earth. What about equality? Will enhancements be only for the wealthy? We must make these healing technologies accessible, lifting everyone up. And now, the big reveal. For years, we imagined replacing our slow biological minds with perfect machines. But we have been looking at it all wrong. The goal is not to replace the human brain. The ultimate supercomputer is not a machine. It is a partnership. The living, creative, emotional brain working with the speed and precision of our technology. The tools are helpers. The human brain stays in the driver's seat, with curiosity, empathy, creative genius. AI, BCIs, and neuromorphic chips become powerful tools we control, the ultimate co-pilots, to cure disease and explore the stars. It is a future that enhances our humanity, filled with awe-inspiring possibility. Boom.